Find the slope of the line through the points -5, -3, and 2, -7. There are two ways to do this. The first way I'm going to show is by plotting the points on an axis, drawing the line that crosses through the 2 points, and counting the vertical change versus the horizontal change from one point to another. So the second way we're going to also calculate it is by actually using the slope formula. So let's start first with actually graphing these points on an axis. So I'll first plot the first order pair, -5, -3. So if I'm going to plot -5, -3, I'm going to start from the origin and move 5 to the left and 3 down. So 5 to the left and 3 down. That would leave you a marking right about here. The second ordered pair, 2, -7. We're going to start with the origin and move 2 to the right and 7 down. So that would leave us with a marking about, this should be our 2, -7. So I'm going to sketch the line through these 2 points just so that you can see we have a definite slant to this line. And now our goal is to calculate the vertical distance from one point to the other, as well as the horizontal distance from one point to the other. Now, an important thing to think about here is you want to first decide which ordered pair you're going to start with. So are you going to start with -5, -3, or are you going to start with 2, -7? So we're going to start with -5, -3. I'll show you that way first, and then we can compare to what happens if we start to 2, -7. So starting with -5, -3, I remember that slope, we use M to stand for slope, is calculated by the vertical change over the horizontal change. A lot of people like to shorten this by saying rise over run. And so if I'm calculating the vertical change from one point to the other, I notice right away that it looks like we've got ourselves 4 units from the first point to the other, vertical change. And then the horizontal change, it'll look like we have, I believe it's 7. Now, when we actually write the slope, we want to keep in mind that the direction you moved to get from one point to the other will matter with what sign you're supposed to put on these numbers. So if you notice that we actually move downwards for the 4, that indicates we will have a -4 in the numerator for our rise. And if we look at that we moved 7 to the right, that would indicate that we have a +7 in the denominator. So we actually have calculated our slope. The slope is -4 over 7. And you'll also notice that kind of makes sense with our understanding of negative slopes. Lines with negative slopes decrease from the left to the right. Now, I also want to talk about what would happen if you started counting from this to -7 first to see how you're going to get to -5, -3. So I'm going to look at that a little closer, and the numbers will still be the same. So again, if you calculate your vertical distance, you will get 4 again. You can kind of tell just by looking at the other 4. And then if you calculate your horizontal distance by counting, you actually get 7, just like we did earlier. But what's slightly different is the direction we moved. So notice starting at 2, -7, we went up 4. So if we were writing our slope, again, slope is rise over run. We'll use M to designate slope. When I'm looking at starting at 2, -7, I'll notice that I went up 4. So that would indicate that my 4 in the numerator is positive. And when I look at where I've traveled, I moved left 7. So left 7 would indicate that I have a -7 in the denominator. So when you compare the answers that you get from starting from 5, -3, traveling to 2, -7, that's this answer. And starting at 2, -7, traveling to -5, -3, that's this answer. You'll notice that they both mean the same number. They are both -4/7. And just so that you are clear on this, remember when you have a negative fraction, so if we're looking at -4 over +7, having the negative sign in the numerator is the same as having the negative sign in the denominator, which is also the same as having the negative sign in the middle of the fraction bar. And sometimes you'll notice that you'll look at maybe one form over the other, especially when you're calculating the slope starting from the 2 different points. And then if you're simplifying, a lot of times you'll see maybe the answers in the back of the book sometimes have the negative sign in the middle. But our particular textbook likes to throw the negative sign in the numerator, so I see that more often. So that's calculating the slope of the line through 2 points, actually by looking at the points plotted on the axes and counting the vertical distances versus the horizontal distances. The second way we're going to find the slope is by actually using the slope formula. So just to remind you what the slope formula is, that is the calculation of the differences of the y's over the differences of the x's. And you'll notice that each of the y's has a different subscript as well as the x's to indicate which point you are taking the x value and y value from. So if we're looking at this a little bit closer, for instance, I might call the first point that I see, that would be the -5, -3. I'll look at that ordered pair as x1, y1. And then the second ordered pair that I see is to look at it as x2, y2. So if I want to calculate the slope, all I have to do is plug in those x values and y values to the formula. So that would leave me with y2 would be -7, y1 would be -3. So I have to be careful when I subtract a negative. I'll also be looking at x2, which is 2. Subtracting off x1, which is -5. Again, when you subtract a negative, you have to be careful about the use of parentheses. So if we're going to look at the slope this way, -7 minus a -3 will leave us with a -4 in the numerator. And 2 minus a -5 will leave us with a +7 in the denominator. So that is calculating the slope of a line through 2 points using the slope formula. And as you can see, this answer, -4/7, agrees with the answer we found about finding the slope by looking at the points. Now, a lot of you are probably thinking, does it matter which point we call the first point and which point we call the second point? My answer to you is no, it doesn't matter. The last example we did on the previous slide, we noticed that we called -5, -3 the first point and 2, -7 the second point. So I'm going to switch it around and I want to just determine if we're going to get the same answer. So let's call -5, -3 the second point. So that would mean that we have this labeled as x2, y2. And 2, -7 as x1, y1. So if we're going to plug that into the formula, we're going to remember that y2 in this case happened to be -3. So we're going to subtract off y1, and in this particular case, y1 is -7. We'll also keep in mind that x2 in this case was -5. And x1 is 2. So if we simplify this expression, the numerator is a -3 minus a -7 is going to give us a +4. And the denominator is -5 minus 2, which will give us a -7. And you'll notice that the slope you just found agrees with the last slope. I think the only difference you might see is that the negative sign is located in the denominator as opposed to the numerator from the last example we just did. But we already talked about how that is really just talking about that the slope is negative. So you've just seen two ways to actually calculate the slope. The first way by drawing the actual line and counting the vertical distance and the horizontal distance between the points. And the second method was to actually plug the ordered pairs into the slope formula. So you can choose either method. You might notice that some points that you're given lead to you choosing one method or the other.